Continue to explore our packaging strategies. This time we are going to look at how we can package our application using Docker. In other words, we'll look at the right way to create a Docker image for our Java programs. Just a disclaimer, I'm not going to teach how to work with Docker. I'm assuming you know Docker and how it works. If you don't know Docker, you can find loads of sources in the internet for free. And I strongly suggest you to pause this lesson and try to learn more about Docker, as it is a very important, let's say, technology for any senior developer, right? So let's look at traditional way of building a Docker image. So as you can see here, we have the image that we are gonna start from. So in our case, OpenJDK 14, and then we load our jar into our Docker image, expose the port 88 because you have our web app running as well, and then you just run the jar with the usual command here. Then we could build this. Let's have a look. And then you can see that we load our fat jar on this step 2 here, and this could work fine for most of the application, but there is an important issue here with this approach, and if you don't have experience with Docker, you will not even realize that. But since this course is for senior developer and you're going to be seeing here advanced topics, we are going to discuss a little bit about this approach and what's the correct way of doing things. The main issue here is because we are not leveraging from Docker layers. So we are adding our fat jar with everything in the same Docker layer. So this fat jar has our libraries and Spring and our code in the same layer, and we are not able to use the cache layers, right? As we already saw in the previous lecture, the Spring Boot fat jar contains all application code and third-party libraries, and it's put everything in the single layer. So let's have a look what you have at the moment. So that's it's what we see where jar. So that's everything you have inside our jar, right? So you can see that it's not really separated between libraries from our code or Spring stuff. So in order to make this easier to understand, I will start with showing how this should be from the jar perspective. So the first thing that we do, you set this configuration to enable layers, and when you enable layers, our final jar will be a little bit different. And let's see how it's our jar now. Here I'm running a Java command to see the content, and you see now that the content is divided in dependencies. Spring Boot loader, snapshot dependencies, so the dependencies that we have in our code that it's in snapshot version. Then we have our application, right? So our code, it is based on this layer, and the dependency in this layer. And since we know where is each part of our application, it will make our life easier to build a better, more optimized Docker image. And so I think worth to extract this jar as well, and then you can see how things it really is in the final. Let's see. The extracted, let's make it easy. And then you can see here that have application dependency and snapshot. And let's look at the finder how things is organized. You can see on our extracted jar here we have application dependency, snapshot dependency. Snapshot dependency will be only our local models, because we have set those as snapshot mode. So you can see common feed and fork that comes from our local versions here. And then we see in the application, let's see dependency first. Dependency, you have library and all the libraries are dependencies. that we have in our application. Then finally you look at our application, and inside our application we're going to have our module info class and also our local classes, right? So you see com, then we're going to have Sosa, my trade, runner, and then you see our classes. And the same way you can see the public here as well with our test CSS from the previous example. And so yeah, you can see that now we have things separated correctly, and now we are able to build a more optimized Docker. And the right way to do that, it is let's show that how our Docker should be. So now you can see that we changed slightly our Docker file. So basically we still have the same Docker image here from the OpenJDK 14, but now notice that we added as builder, because we are going to have some intermediate images for have the final jar, and then we are going to have another step with a final image with our code dependencies and everything that we need. So basically on this step here we are basically bringing our jar as we had before, and then we run our Java extract the same way you run local to have all the folders that we have here, right? And then we start a new image from the OpenJDK, where we are going to just copy things from the previous image to our local image. So, and you can see here we have brought everything on the root, and then we just run our application pointing to this launcher. This is a Spring Load launcher, and this is how we run those jar that it's built with Spring Boot Maven plugin. Before you didn't see because things was on the manifest. So if you go to our application, you can see in the metadata Maven manifest. We can see that the main class it's pointing to this jar launcher, and only then after Spring will be calling our start class, that it's our own one. So, and when you are not using this metadata information, we just point straight to the Spring, and then it would make sure to load all the dependencies based on the information that is on the layers info. So you can see on the layers it will be pointing to our libraries and to the Spring loader and our snapshot dependency. So that's how the magic works. So layers would be read by Spring loader. And yeah, so let's see how things works when you are using this didn't work because we need to be on the root of our project. So then we will be building our image, and you can see that from our image we start to bring dependence, and each step here it's a layer from Docker. So, and as you can see, the Docker didn't build this layer again, but instead used the cache, because I already run this this building before I started recording, and Docker already had those layers in the cache, and because nothing has changed, they don't need to, Docker doesn't build the layer again, right? As you can see, it's using from cache, including our application, it's using from cache as well, because I run before and I didn't change the application, so the cache was used. So if we go to our application and we just change, let's say here from 10, let's say, there's a small change, and we go and run the build again. This is the Maven build, and then we will go and run the Docker build. We'll see that it will be very interesting that now our application was not using the cache anymore, but instead was build a new layer. So this is speed things up, because as you leverage from the cache, when you're trying to upload our final Docker image to the Docker registry, that will be sending only this layer that was built now, and this will be faster to upload and the same to download, because on the server because again we'll just download this layer, and also save space on our server registry, because as you can see, only a new layer with a small part of our application will be built. So not those heavy part of our application, that is the dependence layer, will not be built again, right? And so that's it. So I hope you have found that interesting, and see you in the next lecture.